Yeah. Um, Hi all. Very good evening and welcome back to the 11th week of TA Live sessions for AI SMPS. And yeah, so today we're going to discuss some questions from week 11 and basically cover some questions related to the topics like reasoning, logic, forward chaining, backward chaining, and as we have been trying. So hopefully this time the questions are relatively easier. So like I said in the previous week as well, the previous week was one of the easier weeks of the course. Similarly, the current week, week 11, and also the coming week, week 12, are relatively easier weeks. So hopefully we'll be done by the questions a bit sooner. So the doubts that have been pending related to some of the questions from the previous live sessions that some of you have requested. Hopefully, we'll be able to cover it today. Also, one quick announcement. Um, so, next week, the live session for the 12th week that is scheduled on 16th of October. Um, Usually, our meetings start from 6 and go on till 8. Um, on 16th, we'll probably start a bit earlier, maybe around 5. Uh, this is just because I might have another urgent meeting a bit early on, like around 7, 7:30 or so. So we'll try to start the live session next week a bit early so that we can wrap up our 2 hours a bit early as well. But yeah, that's for next week, and I'll keep you posted on the discussion forum. But just for the information of all of you who usually or regularly attend these live sessions, I am just keeping you informed. Irrespective of the timing, the session will be recorded and shared with everyone, so it's not an issue. But yeah, that's for next week. But for today, let's start this week's questions. Um, all right. Okay. So this is the first question. Um, that we are going to have a look at today. So we are given this setting. So we are given that this P stands for the fact that path is empty, and Q stands for the fact that count is different. Okay, so P represents something, Q represents something, and similarly negation of Q, this not of Q symbol over here, this represents count is same, which is basically the opposite of what Q represents. Okay, so Q represents count is different and not Q represents count is same. Similarly, there would be something for not P as well. Okay, so with these two definitions of P and Q in mind, we are also given two more statements, A and B. Okay, so A says path is non-empty or count is same, and statement B says negation of path is empty and count is different. Okay, so are the statements A and B given below equivalent? If yes, then identify the equivalence formula or else mark the last option. Okay, so basically you are given these 6 options and you have to select which of these options correctly represents the equivalence of statements A and B if there exists one equivalence, and if there isn't an equivalence then we will select option F. Okay, so I hope the problem setting is clear. If not, please let me know. And yeah, I'll every time I'll give you some few minutes to try to uh, solve the question on your own before we start discussing the solutions. Okay, so I hope the problem statement is clear. If there is any doubt related to the problem statement, please let me know. Okay, so let's wait for a couple of minutes and then we'll discuss the solution then. All right, so I see a couple of you or many of you have actually given some solutions in the chat box, and that's great. Um, so let's have a quick discussion of this question because it is pretty straightforward. So let's move to our Jamboard. Okay, so let's write down what is given to us. So P tells us that path is empty. Okay, and Q tells us, sorry, this is a strange looking Q. Okay, Q tells us count is different. Okay, so let's write down what negation of each of these would say. So not P would say path is not empty. And negation of Q would say, as given in the question, that count is same. Sorry about that. All right. Now let's try to find an appropriate representation of statements A and B. Okay. So A tells us path is non-empty or count is same. Okay. So you see we can break down statement A into three essential parts. One is path is non-empty. So how can we represent this? By negation of P, right? Then we have an OR. So this is the symbol for OR, if you remember from the lecture videos. And there's one more part of the statement left, which is count is same. Okay. So that is indicated by negation of Q or not Q. Okay. So this is A representation. Now let's have a look at B. So B represents negation of. Okay. So there's a negation of something, and that something is path is empty. So this is another part. Path is empty, which is represented by P. And in this one, we have an AND, right? This AND symbol. This was the OR symbol. And count is different, which is just Q. And we have the negation of this whole thing. Now, are these two equivalent? What do you think? Yes, they are equivalent, right? By De Morgan's law, simple application of De Morgan's law, this B simplifies to not of P or not of Q, right? So now if we have a look at our options, which of these options do you think fits in with this definition that we just arrived at? That's right. It's C, right? Because we just saw that uh, one side of option C represents not of P and Q in brackets, which is basically our statement B. And then we have that equivalent to, so these three lines in the middle, this is basically the equivalent sign. This is equivalent to not of P or not of Q, which is nothing but our statement A, right? So option C is our correct option. One point to notice here is that there are other options as well among the six options that can be true equivalences in themselves. For example, take this first option A. It is true that not of P is the same as P, right? Because it's basically taking negation twice. So negation of something, which is itself a negation of something, is basically the same thing. While this equivalence is true, this is not true in the context of the statement A and B that is given to us, which is basically that this equivalence does not represent the statements that we are asked to confirm, right? So that's why option A is not a correct option. And similarly for other such true equivalences as well. Okay, why is it not B? Let's have a look at B. So what B basically says is um, the first part, the left hand side of B is not of P or Q. Okay, so let's write that down. Not of P or Q. Okay, so what this basically implies is that not of, what does P represent? P represents path is empty. Path empty, or Q is count is different, right? And if you further simplify it, this becomes not of path is empty. Okay, if you simplify this will become not of P. This or will change to an and by De Morgan's law, and we will have not of Q, right? So this will become not path empty and not count different, which will basically mean path is not empty and count is same. Okay, now let's have a look at the statement given to us. The statement A that was given to us is path is non-empty, which is what this is also is, and count is same, which is also what we have got over here, but the difference is this and over here, right? Whereas here we are given an or. Okay, so B is not the correct option because this and or doesn't match either in statement A's representation, neither in statement B's representation. Okay, so was that helpful? All right. Yeah, as I said, the equivalence of B might be true in itself, but it is not a correct representation of statements A and B that are given to us. Okay. For that matter, even option D is a correct equivalence. P implies Q is equivalent to not P or Q, right? But that is also not a correct representation of statements A and B that are given to us. So that's why D is also not a correct option in our question. Okay, any more doubts on this first question? Okay, that's great then. Let's move ahead to the second question then. This is a straight recall based question from the lectures. So given a knowledge base KB of true statements, entailment is concerned with which of the following? We just have to fill in the blanks. So which of these do you think would be the correct option? Okay, some of you say option A is the correct option. What about the others? Okay, so I see there is a confusion between options A and B. And okay, so uh, just to resolve any queries that there might be about whether A and B are the same or not. So A and B are different options which mean different things, right? So option A says that entailment is identifying statements that are necessarily true as a consequence, and B says entailment is identifying statements that are possibly true as a consequence. Okay, so the key word over here in these two options are necessarily and possibly. Okay, so when some facts or statements are given to you in a knowledge base, you inherently assume that whatever statements or facts you are given in the knowledge base are true. Okay, but when you make deductions based on the facts given to you in the knowledge base, that those deductions, the deductions that you make, the truth value that will be assigned to them is not certain, right? So entailment concerns with only those statements which are necessarily true as a consequence of your deductions, not possibly true. If it's possibly true, it won't be called an entailment, right? It will just be called a deduction. If I have to give an example, think of something like this. Say that your statement A says Harry is the sorry about that. Harry is the son of James. And let's say B statement B says that Harry is a friend of Ron and Hermione. Okay, so given these two statements, something that is necessarily true that you can deduce is that would be an example, uh, would be something like James is the father of Harry. I'm not writing the whole thing because of my horrible handwriting, but I guess you can get the idea. Okay, or something like Ron is a friend of Harry or Hermione is a friend of Harry. Okay, because that is just putting the same thing in a different way. Okay, these are necessarily true, but if you make certain deductions that are not necessarily true, they won't be called entailments. Okay, so entailment has to necessarily deal with necessarily true statements, necessarily true uh, deductions or consequences, right? So the correct option in this case would be option A. Yeah, as one of you said, B would be proof, A is entailment. So you can prove a number of things using the facts that are given to you, okay? But you can entail only things that are necessarily true. All right. If also, I think professor has gone into detailed examples in his lecture video. So if there is any remaining doubt, I would encourage that you revisit the lecture videos, and there would be some helpful examples and explanations to help you out. Okay. Shall we move on to the next question then? All right. So this is the third question. So right just now we discussed about entailments. So which of these do you think, these six options again given to you, A, B, C, D, E, and F, which of these would be valid entailments? Okay. So this might require some time for you to try to simplify and solve on your own. So I'll also give you a couple of minutes. You can try to see which of these are valid entailments, and then we'll have a discussion about what is true and what is not. Okay. Okay, so I see many of you have already shared your uh, potential answers in the chat box. So let's have a discussion on which of these are valid entailments, and let's consider each of these options one by one. Okay, so the first option is P implies Q. So we are given P implies Q and P, and we have said that we can entail Q. Okay, so is this true? So when we are given P implies Q, we are given P implies Q and P. We can imply Q, right? Exactly, by modus ponens. Yes. So we can say that this option A is a valid entailment. Okay, so option A is correct. Now let's have a look at option B. Okay, we are given P implies Q and not of P. Can you imply something based on this? What do you think? We cannot, right? When we are given P implies Q, we can simplify this and write this as not P or Q. Okay, so these two entities, not P and Q, these two together when combined with an OR function, then they can be true. Okay, but given just not P, we cannot say we cannot make any deductions about Q, right? So um, yes, so as one of you pointed out, when P implies Q and not Q is given, then by modus tollens we can deduce not of P. But reverse is not possible. Okay, this is not when we are given P implies Q and not P, you cannot make deductions about Q. So option B would be incorrect. And let's consider option C. Okay, so option C tells us not of P implies Q. So let's simplify that. Not of P implies Q, which is not of not P or Q, which is not of P and not of Q, which is basically P and not Q. Okay, so now you see they are connected by an AND. Okay, so this AND will be true only when both of them are true, right? So both of them have to be true. So P is true and not Q will also be true. So if we look at the left hand side of our entailment, we are given negation of P implies Q entails not Q, which is true, right? So C is also a correct option. Okay. All right. Let's look at D now. So D says given Q implies R and P implies Q and not P, can we deduce something about R? Okay, so P implies Q and not P. Just like we saw, we cannot make any deductions about Q. And since we cannot make any deductions about Q, we also cannot make any deductions about R using this Q implies R. So D is also incorrect. Okay, what about option E? We are given P is true and Q is true. Can you entail and say P or Q is true? Yes, we can say, right? Because when we are given that both P and Q are true independently, the union or OR of them will also be true. So E is also a valid entailment. What about option F? You are given P or Q is true. Can you entail and say that P will be true? No, we cannot say. Exactly. Right. So P or Q is true together, but P separately is not necessarily true in case of option F. So F is also not a valid entailment. Okay, so the correct options as we saw are A, C, and E. Okay, any doubts about this question? Okay, C. Okay, let's go over
Sir, could you repeat the D one again?
Sure. So there are two requests, one for option C and one for option D. So let's go over these two once more. So let's go over option C first. So option C tells us, let's consider the left hand side of the entailment first. Okay. So here we are given not of something in bracket. Okay. And what is in bracket? P implies Q. So let's write that down. Removing all of this. So we are given not of P implies Q. Okay, so by the way, this is given in a second bracket, which basically implies this is just one of the just one fact in the knowledge base that is given to you. Okay, there could have been other facts in the knowledge base as well, but here you have given just one thing. Okay, so for now I'm removing this second bracket just for the sake of clarity. Now, just think about this P implies Q part. We can write this as not P or Q. Okay, if you have any confusion about how we can write this like this, you can try to draw the truth table and see whether these two are equivalent or not. Okay, you can write down P and Q, uh, and then P implies Q, and then not P or Q, and then you can assign them the different values 0 0 0 1 1 0 1 1, and you can fill in this column and this column, and you'll see that they are both equivalent. Okay, so this is something that we know. So let's replace this inside our bracket. So we are replacing P implies Q by not P or Q. Now when we expand this by De Morgan's law, what we will have it, so when you have something like not of A or B by De Morgan's law, that becomes not A or gets converted to and not of B, right? This is what happens. So we apply something similar over here. So this becomes not of P. This OR gets converted to an and not of Q. Now this not of P is essentially just P, right? Because negation of something is itself. So P and not Q is what we have simplified our this expression to. Okay, now both P and not Q are true as per the knowledge base. So based on this, we can say that P is also true and not Q is also true. Okay, because only when these two are true, we can say that P and Q is also true. P and not Q is also true, right? So this expression very correctly entails not of Q. That is, given this statement, we can say that not Q will also be true, necessarily be true. Okay, so that is why option C is correct. Now let's have a look at option D. So let's write down what option D said. So option D, you're saying Q implies R is one fact given to us. Q implies R. Then we have P implies Q. And not of P. Okay, so there are three facts in our knowledge base that are given to us. One is this one is this one, and one is this one. Okay, so um, we are given a singular fact about P, which is negation of P is true, and we are also told that P implies Q. But we just saw that given P implies Q and not P, we cannot make any deductions about Q, right? If we were given just P instead of not of P, then we could have deduced Q. But since we are given not of P, we cannot say that Q is also true. And since we cannot say anything about whether Q is true or not, we can also cannot we also cannot use this first fact that is given to us to make any deductions about R. Okay. So because of this, the entailment that all these three facts together make not R true is incorrect. Okay, we cannot entail not R. Okay, so I hope that cleared up any doubts that were there. Any more doubts on this question?
No, sir, thank you.
Okay, that's great then. Um, let's move on to the fourth question then. So the questions 4 to 7 will now be dealing with a certain problem statement that we are going to see in a moment. So this is the problem statement that is given to us. So we are given a set of rules, which are these A, B, C, and D, and all of these rules are given in the knowledge base in an implicit quantifier form. Okay, which you might recall from the lecture videos. If you don't recall, then no issues. You can revisit the lecture videos and see what exactly is meant by this. And along with these rules, you are also given some set of facts in the knowledge base, which are these small alphabets A to F. Okay, so if I have to explain one of these rules, so this let's consider this first rule. Okay, so first of all, this it's okay. So let's consider the left hand side of rule A. This says double vaccinated question mark X, capital X. Okay, so this question mark capital X is nothing but this indicates that this is a placeholder for a variable. Okay, so let me just write that down. So I'm not writing full double vaccinated. Okay, double vaccinated. This basically implies that this is a variable, which is that this could take multiple different values. Suppose you were given that uh, Ram is a person X, so you can say that double vaccinated Ram is true or not true, depending upon some deductions or something that you make. Okay, so this not of if a variable capital letter is preceded by a question mark, you can say that that is a variable. Okay, let's go back to our setting. So they say that if a person X is double vaccinated, then this implies that this person X can visit the concert. Okay, so double vaccinated X implies can visit X comma concert. Similarly, uh, rule B implies that if person X is not vaccinated and a person X has, this is the AND symbol, and the person X has RT-PCR test as negative, then both these together imply that person X can visit the concert. And rule C says that if a person X is single vaccinated and this person X gets a jab, both these two together imply that X is double vaccinated. And the last rule says that if X is not vaccinated and X is fully isolated and X gets tested, then all these three together, because all these are connected by AND operators, all these three together imply that the RT-PCR of X is negative. Okay, so these are the four rules that are given to us, and the facts that are given to us are about some individuals. So we are given that a person named Abha is double vaccinated, person named Arnav is double vaccinated, a person named Anisa is not vaccinated, a person named Ameya is not vaccinated, a person named Aman is single vaccinated, and also Aman gets the jab. Okay, so these are six facts given to you and four rules given to you. Okay, so any confusion about the problem setting as of now? Okay, that's great then. So now let's move on to the questions based on this problem statement. Okay, so the first question asks us, or the fourth question, which deals with this particular problem setting that we just saw, we have to identify the rules that participate in the move gen function for forward chaining. Okay, so basically you have to apply forward chaining given this set of rules and the facts in the knowledge base, and then you have to identify which of the rules are participating, and you also have to count the number of instances each rule is taking in the movegen function. Okay, so for against each rule, write the number of instances of that rule from that form the movegen with the above facts, and you have to report that as a sequence of four numbers, which would be something in this format. So if you have these four rules A, B, C, and D, and suppose that rule A is instantiated once, rule B is instantiated 0 times, rule C is instantiated twice, and rule D is instantiated once. So you would report your answer as 1021. Okay, this is just an example of how you would report it, but the essence of the question is basically you have to apply forward chaining, see which rules are participating, count the number of times a rule is appearing, and then report those numbers. Okay, so I'll give you a couple of minutes to solve this problem. I'll go back to the rules and the facts given to you, and then we can have a discussion on the solution. All right. So sorry about that. Yeah. So I see that uh, a couple of you have given solutions in the chat box, and let's have a quick discussion of the solution. Before that, I'll also go over briefly what is forward chaining. For a detailed explanation, I would suggest that you revisit the lecture videos. That will be best. But for now, we can have a quick discussion on what forward chaining is. So, and also I'm borrowing this straight from the lecture videos myself. So suppose you are given some facts in your knowledge base. Okay, so suppose this is your knowledge base, and let's say these little squares represents the facts that you have. Okay, now let's say based on these first two, you made a deduction. Okay, then let's say based on these two, you made another deduction. Okay, so you see that your knowledge base is expanding. Okay, now let's say based on these two, you made another deduction, and now let's say based on these two, you made another deduction. So again, you added some more facts to your knowledge base, but let's say after this, you cannot expand anymore. You cannot add any more facts based on deductions, right? So that's where you will stop. So this is essentially what is forward chaining. You take your facts that are given to you in your knowledge base, make some deductions based on the rules that you have, and then you further use them to make some more deductions using the same rules that were given to you. Okay, and you proceed in a similar fashion. So that is what forward chaining is essentially. And yeah, so let's write down the facts that are given to us in our knowledge base. So the first fact that is given to us is double vaccinated ABA. Okay, so this is one fact that is given to us. Another fact that is given to us is double vaccinated Arnav. Okay, then we are given not vaccinated Anisa. Not vaccinated Ameya. Single vaccinated Aman. And gets jab Aman. Alright, so we have listed the facts that are given to us. Now let's see which rules can we apply. Okay, so the first rule, rule A, let's see what are the preconditions for that rule. This is very similar, by the way, to the forward state space planning and that we saw earlier, and also very similar to the rule-based systems that we saw in the previous live session. Okay, so you can draw your analogies yourself and try to form connections between the different methods you have been learning. So, okay. So rule A says that if a person X is double vaccinated, then this person X can go to the concert. So let's see if we are given anything about a person being double vaccinated. Turns out we are told that Abha is double vaccinated. So we apply rule A and we can say that Abha can visit the concert. Okay, so I'm not writing the whole thing. This is just can visit concert. Okay. Similarly, Arnav can also use rule A and we can say that can visit concert will be true. Okay. Also, nothing else has double vaccinated over here as of now. So we will stop with rule A and go back to rule B. So rule B says that if a person is not vaccinated and person X has RT-PCR negative, then this person can visit the concert. Okay. Now let's look at, so we have some information about some people being not vaccinated, but we do not have any information about any person being RT-PCR negative, right? So we cannot use rule B anywhere because we don't have any information about RT-PCR, and also this is an AND operator over here in the AND. So we need both the person to be, we need the person to be both not vaccinated and having RT-PCR negative in order to use this rule. So rule B will not be present in our forward chaining at all. Let's look at rule C. So rule C is that C says that single vaccinated X or a person X gets jab X, and these two together imply that X is double vaccinated. Now we have Aman is single vaccinated and Aman gets a jab. Okay, so using both these together, we can apply rule C and say that double vaccinated Aman. And because this double vaccinated fact has now been added to our knowledge base, we can again use rule A to say that Aman can visit the concert. Okay. Now let's have a look at the last rule that we have, which is rule D, which says that X has to be not vaccinated, fully isolated, and gets tested. Again, we see that there are some facts about people being not vaccinated, but no facts about these people being fully isolated or getting tested. So once again, since these are also connected by AND operators, we cannot use rule T. Okay, if these were OR operators, then we could have used the rule. But since these are connected by AND operators, we cannot use rule D. So again, rule D will also not be used in our forward chaining method. And you can see that given the facts that you have in the knowledge base currently, you cannot use any more rules, right? So you have to stop right there. So this is what our forward chaining tree looks like from left to right. You can also represent it top to bottom. That will be another view of the same thing. Let's have a look at how many times each rule was instantiated or used. So rule A was used once, twice, and thrice, right? So 3 for this one. P was not used at all, so 0. C was used once and D was not used at all. So our answer would be 3010. Let's have a look. Yes, the answer is 3010. Suppose D gets satisfied, can it be used at P? To address your query, if you can deduce some facts based on the rules and the facts that are already given to you, knowledge base and the facts that you have already deduced, if you can deduce some more facts that allow you to use a certain rule, then you can always go ahead with that and keep on doing forward chaining until you reach some goal that you want to reach. But if you are not able to get the satisfying preconditions for a rule, then you cannot use that rule. It's as simple as that, right? So that applies to any rule, not just rule D and B. So I'll show you one. So we drew our forward chaining tree from left to right. I'll show you one proper top to bottom, and I'll zoom in a bit, and I'll let you go through this for some time, and then we can move on to the next question or discuss some doubts if there are any. Okay.
Sir,
Yeah.
I was just pondering on the entailment question.
Uh-huh.
I got a bit confused again. That given uh, P or Q,
Okay.
then will it imply to only P?
No, it won't, right? Because when you're given P or Q is true as per your knowledge base, you can say that P or Q, that term together is true. Okay, so P and Q independently you cannot be said to be true. If it had been P and Q, then you could say that P is also true and Q is also true. Okay,
Yeah, okay. Thank you so much.
yeah. And to address your query, Abhishek, uh, comma does not necessarily represent anything over here. Uh, were you asking about in context of something specific? No, I don't think in general comma represents. Oh, okay, you meant in terms of your knowledge base that we saw in the previous question. Okay, let me just go back over there. If you were referring to this thing, then this is just different facts getting stated, facts in the knowledge base that are getting stated together, right? So this basically means that P is true and Q is true. Okay, these are two separate facts in the knowledge base. That is what is represented by this comma over here. Similarly, here comma represents that Q implies R is a fact, P implies Q is a fact, and not P is a fact. Okay, other than this, does a comma doesn't have any relevance or significance. I hope that addresses your doubts. If there are any other doubts, please let me know. And we'll wait for maybe a couple of more minutes and then we'll move on to the next question.
Sir, can this image be made more readable? Actually,
Sure.
I'm not able to read only.
Yeah, I'll zoom in a bit more. Is this slightly better?
Yeah, better. Thank you.
Yeah, I think I know some of it is getting cut from the screen, but I think you can reduce it yourself. So I'll just leave it in this configuration. Yes, and to address one of your queries in the chat box, as one of your friends also said, A implies B is not equal to B implies A. Okay, it's unidirectional. It's basically like if and then, right? So if A, then B. You cannot say the uh, other direction is always true. And you can also reduce that based on the truth value. So if you have a small formula and you want to see whether they are equivalent or not, try to draw the truth table. Okay, so for A implies B, it will be not A or B. Okay, and B implies A would be not B or A. Try to see whether these two are same or not. That will help you with your doubts. Yeah, I know it's if you have not if you're not familiar with this kind of statements in logic, it can be a bit confusing, but don't worry too much about it. As you practice more, you'll get used to it. These kind of statements are more pretty common in reasoning and logic. So you just need to give yourself some time to familiarize yourself.
Sir, where will we get like these practice problems more?
Um, so for this exam, for this current course, I would say that you can so some of these questions are there in this live session that we are practicing. Some I hope would be uploaded as practice assignments by Bhaskaran sir, And otherwise, you can also just do a Google search about practice questions on reasoning and logic, and you'll get some good questions. I would say if you want to go into an in-depth understanding of this reasoning and logic itself, then this week 11 and 12, is kind of expanded into a whole course of its own, again by Professor Deepak Kemani, and it's called AI Knowledge Representation and Reasoning, AIKRR. If you are interested, you can take that up in the next semester. But yeah, for now, if you want to have some more questions, you can just do a Google search and you'll find some good
I'm
resources.
sorry to bother, but sir, I searched so much on Google. Even on I did not find any examples on Bloxworld also. And the questions in the assignment are really very difficult, sir.
Um, okay, so yeah, so we can try to have a quick discussion on Blocks World today. Um, I did, as I said in the last live session, I had told Bhaskar and sir about the doubts related to FSSP, BSSP, and GSP, and he said that the practice questions in the assignment should give a good basis to solve the assignment, the graded assignment, and I would also encourage you, if you haven't already, to post your doubt, your very specific doubt in the discussion forum as well. Like if you want uh, something about some specific point about the GSP algorithm that is troubling you, then post that in the discussion forum. Okay, if you ask him to post, just give you the solution, then he will also uh, won't be he won't understand which exact point is troubling you or you're having a hard time with, right? So if you can even post like a potential solution that you have come up with, you can post that, and then you can ask that where exactly are you going right or wrong. Okay, so those things Bhaskaran sir said that he can help with, so I would encourage you to do that. But for today, we can also have a quick discussion on Blocks World as well.
Yes, sir. A humble request, if sir has some more questions which are already solved, and if those could be posted, they would really be of very much help to us, because we understand what is taught, and when again a new problem comes, again a new query arises, and we are stuck over there.
Okay. Yeah, I understand that. So the questions that I have access to from the previous offerings of the course, I'm sharing those through the live sessions. But if there are any extra questions, I will request Bhaskaran sir to share those if possible. I will pass
Sir,
on this
I have a
message.
doubt, sir.
Yeah, please go ahead.
Sir, since in this example that not vaccinated fact is not applicable anywhere,
Uh-huh.
if there is something, some other fact like, for example, single vaccinated and get jab is combined to apply RT-PCR negative, can that be combined with the fact of non-vaccinated?
If you had some rule that could work with the given facts in your knowledge base, then you can always apply that rule. That is
So
not an
whenever
issue.
if it is applicable, we can apply.
Yes, exactly.
Okay, sir. Thank you.
Yeah. Okay. And to address another query that one of you have asked, Rocky, will there be a session on 23rd of this month? Um, so as per my schedule or the information that is given to me, 16th October will be the last session that we'll be having, which happens to be the next Monday. And 23rd, yeah, no, I don't think we'll be having a session on 23rd. 16th, next Monday, will be the last live session that we'll be having, and we'll cover some questions from week 12. All right. Okay. So, any more doubts on this question? Yeah. So to address one more query in the doubt, so today I have found some sample questions from nearest neighbor and greedy heuristic. I hope that will help you with savings heuristic. I haven't found a good question on savings heuristic yet, but uh, we will discuss those two solutions today. And if the savings heuristic, and I hope that will help you with the savings heuristic. But if it's still not clear, then maybe next week we can also have a question on savings heuristics. Okay. Any more doubts on this particular question that we just discussed, the forward chaining one? Okay, that's great then. So now let's quickly move on to the next part of the questionnaire. Um, so to quickly address the query, Abhishek, if I suppose you're referring to the knowledge base that is given in your graded assignment, um, unfortunately, I cannot do that before the assignment deadline because that would be unfair to all the participants, right? But we can have a discussion on that knowledge base once the deadline is over, maybe next Monday. Okay. All right. So yeah. So the fifth question was also related to forward chaining, and let's quickly go over it. This was if the forward chaining algorithm runs till no more inferences can be made, which of the following facts will be added to the knowledge base? So what do you think? Okay, yeah. So we just saw that we made some deductions about Abha and Arnav and also about um, Aman, right? So yeah, that is true. If you also have a look at our table of our tree that we just drew, we did make a deduction about Abha. This one made a deduction about Arnav, and we made a deduction about Aman. Okay, so we have can visit for all these three people is true. So A, B, and E are the correct options. This was pretty straightforward application of a forward chaining, and I hope there's no further doubt in this one. Let's move on to the next part, which is backward chaining. Okay, so we just saw forward chaining and now we'll see backward chaining where instead of starting with the given facts, you will start with a specific goal which is can visit concert. Okay, so this is your goal that you'll start with, and then you'll see which of the rules could have led to this rule led to this goal, and then depending on the preconditions of that rule, you will have some some sub goals. Okay, so you'll grow your tree backwards in this way, and yeah, and again you have to do the same thing. You have to see how many times each rule is instantiated, and you have to report the numbers in the final tree the backward chaining tree that you drew. Okay, so to state it formally, you have to find out what are the relevant rules that generate the subgoals and how many instances of those rules will find a place in the search tree rooted at the goal node. And sorry, like in the previous question, you have to report how many times each rule is instantiated. So yeah, I'll again give you some time to try to solve it on your own. And also remember that this is very similar to BSSP that we discussed in a previous live session, and also some of you might have had doubts about it. So if we go through this particular solution, I hope some of your doubts about BSSP will also be resolved. Okay, but that comes later. First of all, try to solve it on your own, and after a couple of minutes, we can have a discussion on what's the correct solution.
So please share the rules screen.
Yeah, sure. Sorry about that. I'll just go back to the rule screen. Yeah, there you go. So yeah, I agree with you, Rocky. We can go a bit fast. So yeah, so let's. So some of you have shared a potential solution to this question. Um, let's go over the detailed solution to backward chaining. All right. So here we have to start with a goal, which is can visit concert. Okay, and this will be the root node for our tree. So now we have to look at which rule could have generated this. Okay, so there are two candidates that could have generated this. One is rule A through double vaccinated, and the other was rule B through not vaccinated, and RT-PCR implies something. Okay, so let's note that down. So one possible way was to use rule A, which said double vaccinated someone implies can visit concert. Okay, I'm not writing the whole thing. And the other way was to be not vaccinated.
Sir, could you please change the pen? It is not at all visible.
Okay, let me write it all over with this. Maybe I'll try a red ink. That will help. Is this better?
Yeah, please write something. Yeah, better.
Okay. Okay, so this could have come through two rules. Let me actually write the rules in boxes. So one of them was double vaccinated X implies this particular goal. Okay, I'm not writing the whole thing. And then the other rule was rule B, which says that not vaccinated and RT-PCR negative. And these two together implied this can visit concert goal. Okay, so these two are the rules that we came across that could have generated this the relevant goals rules that or actions that could have generated this goal. Now let's see how this is decomposed into sub goals. So if we had gone via the rule A route, this route, then this double vaccinated becomes the next sub goal, right? And if we had gone via this rule B route, then since these two are connected by an AND, if you remember from the AND or graphs, we would need something like not vaccinated X and RT-PCR negative. These two together will be the next sub goal if we had gone via the rule B route. Okay. Now this one can be solved with what? Okay. This so there are two facts that straight away solve this. One fact is about Abha. I'm again not writing that down. Okay. Fact A that is given to us. Another fact is about Arnav that is given to us, right? We are told that Abha is double vaccinated, Arnav is double vaccinated, and we could also have gotten double vaccinated by application of rule C. Okay, so another branch over here would be application of rule C, which was single vaccinated and gets jab. Single vaccinated and gets jab together imply double vaccinated, the sub goal. Okay, and this again decomposes into two sub goals together, single vaccinated and gets jab. And again, these two are satisfied by the facts given in the knowledge base about Aman. Okay, so again, I'm not drawing that tree, but these two are satisfied by Aman, which is E and F statements from a knowledge base. Okay, now let's have a look at the rule B part of our tree. This not vaccinated is satisfied by two statements in the knowledge base, which is C and D. Okay, but RT-PCR doesn't have any facts to support itself. RT-PCR, this one, can only be satisfied if we had applied this last rule, rule D. Okay, so let's write that down. So if we had applied rule D over here, then we would have certain preconditions implies RT-PCR, and those preconditions would become the sub goals, right? But as we will see that those preconditions will also have an AND connection there, because we have these AND connections and we don't have any facts to support fully isolated and get tested, so we cannot extend our backward chaining tree any further, right? So we'll stop there. And we have also found or achieved our goal for certain members of the knowledge base. And yeah, so let me show you a refined version of this tree. Okay, so note that here one of the arrows is missing, which is basically that this RT-PCR negative, sorry about that, this would have another extension over here to rule D, which is missing in this graph, and this would have resulted in these three things as sub goals. One would have been not vaccinated, one would have been fully isolated, and another would have been gets tested. There would have been two facts to support not vaccinated, but no facts to support fully isolated or get tested. Okay, so we will have to stop there. These two sub goals cannot be fulfilled basically. And these two can be fulfilled by Anisa and Ameya. Okay, so I'm not writing that down. Now let's count how many times each rule appears. Okay, so rule A appears once and only once. Rule B appears once, rule C appears once, and rule D appears once. Okay, so a solution in this case would be 1 comma 1 comma 1 comma 1. Okay, let's have a quick look at the solution. Yes, the answer is 1 comma 1 comma 1 comma 1. I will let you go through the graph once more and convince yourselves about the solution, and then we can move on to the rest of the, so this is in fact the second last question. There's one more question, but yeah, after this we can move on to the doubts that we had from the previous live session. Okay.
Sir, meanwhile, could you just tell something about unifiable?
So again, I'll have to revisit the lecture videos to say to give the correct definition of unifiable. but I would recommend you revisit the lecture videos, or if it's not helpful, you can post it in the discussion forum, and Bhaskaran sir will address this issue. Yeah, sorry, I cannot help immediately. I'll also have to go and revise the concept, so that's why I'm not willing to share something that might be wrong.
No worries. No
Yeah,
worries. Thank you.
yeah. Okay, so there's another query in the chat. So, if there is a fact that is formed as a result of a rule and can be used in two rules, um, okay, then what would be the first two? Would it be based on timestamp? So we don't have timestamps over here. So your question is if there was a fact that is formed as a result of two rules. Um, so this would be the something like this root node, right? Here also this can visit goal. So here we don't have facts. Here we have goals, right? Goals and sub goals. So do you see that this could have been reached through two ways, through rule A or through rule B. So you drew both the options and you went through the sub goals for both the options. For rule A, you saw that this sub goal is actually satisfied by some facts given in the knowledge base, and also this sub goal, which is this one, this is also satisfied by some facts in the knowledge base. Whereas in case of rule B, this sub goal is not satisfied by any fact in the knowledge base because of the absence of anything that makes this RT-PCR sub goal true. So you will extend in all directions, but you will choose the final solution that gives you this rule A solution, basically, because this works as per the facts that are given to you in your knowledge base. Okay, I hope that helps. In case of forward chaining, you will start with the given facts in your knowledge base, and then you will apply whatever different rules you can apply. If there is a fact that can be applied with different rules, you can apply with different rules, and you can generate different facts based on the application of those different rules as well. Saying something like this. So if you have this in your knowledge base, let's say, and one rule gives you something else, and let's say there's another rule that gives you something else, you can have both things. You can also have this this in combination with some other things to generate something else also. With forward chaining, you'll keep on doing this until you arrive at a particular situation you want, or you can no longer apply any rules. Okay. Yeah. Yeah, so rule B and D are not selected over here. We are just counting how many times these occur in this tree. Okay, these are not selected over here. If you were asked to give a plan of deduction or a proof sort of, then you would go via the rule A route, the left child of the tree. Okay, but here we are just counting how many times each rule is appearing in the tree, search tree. Right? So that's why we are saying that rule B is appearing once or instantiated once, and rule D is appearing once. Yeah. All right. Any more doubts about this question? Okay. So if you will draw these analogies, this is very similar to BSSP, or BSSP is very similar to this. So I would encourage you to try to revisit BSSP also and try to solve it if there was any doubt about it. Okay. So let's revisit the question and just see the last question that was related to this. So the last question was, if the goal is can visit, which we just solved, which of the following goals will be reported as true by backward chaining? So for which individuals do you think we can satisfy or we can arrive at a proof for deduction using backward chaining. Yeah, it will be the same three individuals from the forward chaining example, right? Because here also you can move in this direction and have have the rule for the deduction for ABA. You can move in this direction and have the rule deduction for the final deduction for Arnav, and you could move in this direction and have the deduction for Aman, right? So again, Abha, Arnav, and Aman will be the correct options. Yeah, A, B, and D. Any doubts about the questions? Okay, that's great. So that brings us, huh. So why not Anisa? Why not Anisa? Because if you visit the search tree over here, this is not satisfied, right? We cannot say that we can take this route, because in order for this to be satisfied, sorry about that, in order for this to be satisfied, you need both this subgoal and this subgoal to be satisfied, and this subgoal is not satisfied, right? Because you don't have any facts that support this subgoal. So you cannot say that for Anisa we have a proof or for Ameya we have a proof. Yeah. Okay. So that brings us to an end of questions for week 11. And before, sure, yeah. So I'll just make a quick announcement that I also made at the start of the session, and just in the interest of people who might want to leave early, because we are going to discuss some other things now. We are done with week 11. Yeah, so basically what I was saying is that just a quick information that next week on 16th October, the live session I'm planning to start a bit earlier from 5. So this is not official. I'm just keeping you all informed who are regular attendees of the live session, and it will still be recorded, so even if you can't make it, it's fine. We will go from 5 to 7, and that is because I have an urgent meeting come up on that day later in the evening, so I'll have to give more time to that. So that's why we'll start a bit early next week. Okay. Irrespective of that, we will have 2 hours of session, and I will record the session and upload it, so no worries if you even if you can't make it. Okay. So yeah, that's what I wanted to announce. And yeah, to address one query in the chat box is that um, can we have a quick discussion on for all x and their exist x? Yeah, sure. So for all x, these are basically universal and existential quantifiers. So for all x, certain statement being true, this implies that for all possible configurations of uh, the value that this x can take, this p is true. Okay, an example could be something like for all x, um, you can say that if let's say p represents that, going back to the same example, Harry uh, is the son, or let's say Harry is the father of, or let's say we have something like Harry is a child. Okay, and let's say we have something that says that P implies Q, where Q is that a person has a father. Okay, so this can be X. Okay, P implies Q. Harry is a child implies Harry has a father. Okay, so for all X, this is true, right? For every person who is a child, they must have a father, or they must have a mother, right? So that is something like an example of a universal quantifier. Existential quantifier is basically that it is true only for some certain cases. Okay, there exists some case for which a certain thing is true. For example, if here Q represented that Harry has a brother, okay, so that may or may not be true, right? If Harry is a child, then um, Harry has a brother is not necessarily true. So there would we would use an existential quantifier where for cases where it's every time true, where we would use a universal quantifier or for all quantifier. Yeah, humans are mortal. Yeah, this is a much better example than what I gave. Thanks for that, uh, Rocky and Abhishek. Humans are mortal. Yeah, that is a much better example of use of universal and existential quantifiers. Yeah, so I hope that helps with your doubt. Um, oh, so you want to ask what do we use over here? Okay, okay, okay. Yeah. So basically, you are given that all humans are mortal, right? All humans are mortal, which implies human implies mortal. So if you are given something, let's say Harry is a human, then for all humans, you can say that that human is a mortal, right? So Harry is a mortal. Similarly, for another human, let's say X, if he's a human, then he or she is a mortal. So you'll be using for all over here. Okay. Yeah. I suppose you. Yeah, that's a good example, Rocky. Some humans are. Uh, okay, let's not get into controversial topics. So, human intelligence is not necessarily restricted to a certain subject or topic. Some people can be intelligent in something, some people can be intelligent in other things. But let's say something like all humans are tall. Okay, that is not true. So, there you would use an existential quantifier. Okay, there exists some human who are tall. Okay, that would be an example of existential quantifier. But yeah, for if we take aside the controversial aspect of whatever that we are discussing, but yeah, your statement is also true. This example of some humans being intelligent would also have an existential quantifier. Yeah. Okay, I hope that helps with both of your doubts. Okay. No, I don't think that's what is true, Ram. So you can think of P implies Q as if and then. Okay, so if P, then Q. That's how you can think of it as. And you can, as I said, you can draw truth tables, and you can assign some random things to P and Q. Let's say you assign P as that it is cloudy today, and Q as it will rain. Okay, and then you see via that truth table what are the cases where this will be true, and that will help you better understand of how to put it in terms of, let's say, a natural language like English. Okay, yeah, so since we have lesser time, let's quickly move on to the few doubts. So there are only two things that we're going to discuss today: nearest neighbor and greedy heuristic. Okay, let me zoom in a bit. So here you have the TSP problem as the normal TSP problem, and you are given your distance matrix over here. So you have 6 cities, and you have to find a tour that starts from any one of these cities and visits the all the others exactly once with the minimum cost. Okay, so let's say you start with A. What you will do is you find the X1, which is the nearest neighbor of A that does not violate the tour condition. What is the tour condition over here? That it should visit that only those cities which have not already been visited, and it should also yeah, that is basically the tour condition, and it also should maintain that this city is the nearest to the city that you are considering as a starting point. So if you consider A as a starting point, have a look at the distances that A is related to for different cities. So A is of course related to itself with 0, so you won't consider that. A is far off from B by 16 units. A is far off from C by 15 units. A is far off from D by 4 units. A is far off from E by 3 units, which is the least distance. So you will connect A to E. With the cost of 3 units. Okay, so add A 3. Now you have to look for something from E. So look at E. So again, look at what is the minimum value in this row, except the E comma E column. Okay, so this you won't consider because you don't want to stay at the same city. You want to move away from E. So apart from this zero, the lowest is 3, right? But that will take you back to A, and you don't want that, right? That will violate the tool conditions. So you won't take this 3 either. You will take 6, which is the next nearest neighbor, okay, which is from E to D. Okay, so E to D with 6 you added. Now you have to look for something from D. So from D again you see that the lowest is 4 to A, but again you cannot choose A because that would mean that you go back to A and that would violate the tour condition. You have to visit each city exactly once without forming any loop, right? So again you don't consider 4, you consider you also can't consider E because you have already visited E, so you'll consider F, right, because that is the next nearest neighbor available. So from D you will go to F with cost 7. Okay, then you have to look for somewhere to go from F. So from F the nearest is C, 2, right, and this does not violate any tour condition. So from F you will go to C with cost 2, and then from C you will go to, you cannot go back to F which has cost 2, so you will go to B which has cost 5. Okay, so you'll go to, and now you have reached B. Now you have only one option to go back to A because you have already visited all the cities once. If you'll go back to A with the cost of going from B to A, which is 16. Okay, so you have arrived at a tour of all the cities where you visited each city exactly once using nearest neighbor method. And if you have to give path representation of the city tour starting from A, then you could go in two directions. You could either go from A to E to D to F to C to B, and then back to A, which you don't need to write. So that would give you the first path representation. Or you could go in a separate direction from A to B to C to F to D to E and then back to A, which gives you the second path representation. So this is basically what nearest neighbor is. Yes, it is necessary to close the path. You want to come back to where you started to. Okay. Yes, Dr. Preeti, we will try to go over Diplox world also. Okay, let's quickly go over greedy heuristic now. So again, you have the same table, and in greedy heuristic, what you'll do is you'll start with, the first thing that you do is you have all these edges basically, right? This distances in the matrix represent the different edges, right? So this basically represents the distance of going from A to B is 16. Okay, so this represents the edge from A to B with value 16. So you arrange all these edges in increasing order and look at the minimum cost edge, which happens to be this one with value 2. If it does not violate the tool condition, you add it to your solution. Okay, so you see that this CF edge has value 2, right? So you add that. Now you look for the next lowest possible um, cost. So you basically, what you're trying to do is you're being greedy over here. You're choosing the lowest cost edges one after the other, right? So the next lowest cost edge is this AE. Okay, so you had added C to F. Next you added A to E. Now next you will add this edge with cost 4, which is A to D. Okay. Now next you will add the next lowest cost edge, which is B to C. With cost 5. Now next lowest cost edges with 6, but if you use this one D to E, this will violate the tour condition, right? Because this will cause a closed loop between A, D and E, and you won't be able to get out of it. So you won't add DE, you will add DF with the next lowest cost, which is 7. So D to F. Okay, and this completes your tour. Okay, so again you can go from um, A to D to F to C to B and then to E. Okay, you can connect these two because you don't have any other option now. And the other way of looking at is this A to E to B to C to F and to D. This is your greedy heuristic. Okay, this was your greedy heuristic. Now let me quickly give a idea about blocks world domain. So blocks world is basically you have some things on a table. Okay, you have certain blocks kept over there, right? And let me actually try to see some solution. So can you remind me in which week was blocks world? Yeah, so to address some of your doubts, saving heuristic, I don't have a problem with saving heuristic right now. So if try to solve saving heuristic with the knowledge of these two methods that we just saw. If it's still unclear, in the next week we can have a discussion on saving heuristic. Okay, week 8. Let me go to week 8. Okay, so this is your blocks world. Okay, so let me zoom in a bit. I hope this is clear now. So your predicates are basically on x comma y, okay, which indicates that your box x is placed on top of box y, something like this. Okay, on table x basically means that your x is on table x means that x is on the table, something like this. Then your holding x basically indicates, give me a minute, I'm getting an urgent call, I'll just be back in 2 minutes.
Sir, we are okay with the predicates.
Hello. Where are you, sir? Where? Okay, okay. I'm coming in 1 minute. Yeah, so sorry for the delay. I got an urgent call and had to take it. Sorry for the delay and thanks for understanding. Yeah. So yeah, okay. So you were saying that yeah.
So we are already sound with the predicates and operators. Since we are running out of time, you can directly hit the problem, sir. No issues.
Okay, okay, that's great then. Thanks for that. Yeah. So since these are clear, so okay. So do you want me to discuss any specific problem? Um,
We are starting from 6.
Okay, which of the following are applicable actions for the above problem? Okay, so the above problem is that you are given this start state and you are given some goal that you want to reach where A is on top of D and B is on top of C. Okay, so applicable actions would be dependent on your start state, right? So start state has A on the table, D on top of C and B on top of E, and your arm is empty. So based on this, the different actions that you could apply is let's see. Can you do pickup A? You can do pickup A. So that is supposed to be an option. Yes. Can you do pickup B? You cannot do pickup B because pickup is only for uh, items that are kept on the table, right? So if you had to pick up B, you would have to do unstack, right? So that's why pickup B is not a correct option. Pickup D is also not a correct option. Put down A is also not a correct option because for putting down A, you must have it in hand. Put down B is also not correct. Put down D is also not correct. Stack A comma D is also not correct because to stack A on D, you need to have A in hand first, right? Stack B comma C is also incorrect. You can unstack D from C and you can unstack B from E. That that gives you the three applicable actions. Was that clear?
Yes, sir.
Okay, great. Then let's move on to 7. Let FSSP find the shortest plan. Which of the following can be used as the last action of the shortest plan? Okay, so the last action of the shortest plan. Okay, so even if you use FSSP and if you are concluding your finding your final plan, the last action would either be that you are stacking A on top of D or B on top of C, right? Because that will help you to reach your goal state. Either you finish this part of the goal first where stack A on D, or you finish this part of the goal first where you stack B on C, right? So both of them could be candidates. So I think stacking A on D and stacking B on C should be the two options. Yeah, that sounds good. Any doubts in this one?
If this was BSSP,
Yeah, if this was BSSP, let's have a look. Then you won't have a last action, right? Then you would have a first relevant action, right?
yeah, first.
Yeah, so then yeah, it would be the same answer, right? Because for solving, for having the goal state where A is on top of D and B is on top of C, uh, you can reach it in two ways, either by application of uh, stacking A on D and stacking B on C. So those two should be the relevant actions, I think. Okay, put down D is also an option over here. Okay, how is that coming? Okay, put down D should not be a relevant action, I suppose, because that is not what is leading to the goal state immediately. Have you, any of you raised this in the discussion forum? Or has Bhaskaran sir commented anything about it?
No, sir, we don't know.
Okay, then it's okay. As of now, my understanding says that put down D should not be here. But I will also go and revisit BSSP once more and see what are the criteria for deciding if an action is a relevant action. In the meantime, I would suggest that you post this in the discussion forum with this specific doubt that uh, can Bhaskaran sir please help with how put down D will be a correct option in this case. Okay, similarly, if you have certain specific doubts in the upcoming questions, you can also post that similarly, asking what specific doubt you have. That will help him also answer. And I will also go through these questions once more, and we can discuss this in the next live session also. Would that be good?
Yeah. Sir, if it is put down D, then it should be put down D also, no?
Not put down B because, okay, so
The
the,
diagram, can you please check?
yeah, so here you are given B on top of
Yeah,
C.
then it should be D also, no?
Yeah, no, but C is not on the table. So C is on top of something else, let's say, as per this goal description, what I can think of. Uh,
Yeah, okay. Directly B we can place on C.
yeah, which would be stack. So stack B on C is one correct relevant action that we all agree with. Stack A on D is also a correct relevant action. Why put down D will be a relevant action is what I cannot understand as of now. But I will go through the method once more and I'll get back to you on that.
Yeah, no problem.
Okay. Yeah, this is the goal state, Namita. This left hand, this right hand side figure, goal description where A is on D and P is on C. Okay, so this one. Ah, okay. So here you have on table D. So is this where the put down D is coming from? In order to satisfy this sub goal, you need to have put down D. Ah, okay. So this is where it is coming from. Ah, thanks for pointing that out, Namita. Yeah. Thanks for pointing that out. Yeah, thanks for the hint. Yeah, this is where put down D is coming from. Yeah, that solves all queries. Okay. So for each subgoal in your goal state, you have one relevant action, right? One or more relevant action. So for on table D, you have put down D as the relevant action. That's as simple. Yeah. Okay. I hope that resolves that doubt. Let PSSP find a valid plan. Which of the following can be the action that is first added to the plan by the planner? Okay. The first action that can be added would be, let's see, stack A comma D and stack B comma C. That makes sense, right? Because only then you will be arriving at your relevant actions, right? And that would lead to your goal. I hope that is clear.
Sir, given the answers, we can follow. But when we do without the answers, then things go wrong.
That is just practice, I would say. So you saw that even I got confused with the put down D. So it's not certain that so it's basically just practice, right? So the more you practice, the more you get used to it. I will try to request Bhaskar and sir to upload a
Yeah, sir,
few.
if you could give us few more problems for practice with solution.
Yeah,
Really a request.
yeah, I understand your request and I will forward it to Bhaskar and sir, and I'll try my best. But that's the best I can promise. Um, let's see.
Thank you. Thank you so much.
Okay. So SSS star. So we had an in-depth discussion on SSS star in the previous week. Try to go through that. If it is still not clear, we can go through it once more in the next live session, but it will take a lot of time. So that's why I'm saying try to go through it once more. If it's not clear, then sure we can have a discussion. Yeah, I will try to find something on saving heuristic as well. Okay, thanks for your patience. Sorry for the delay again. Um, no, Soumya, as I said many times in previous live sessions, I don't have any access to previous question papers, so I can't help you with that. If you can find some colleagues of yours who have taken this course before who might have the question paper with them, then that will be helpful for you and others. But yeah, I don't have access to any last sem question papers. I only have access to the last sem assignment questions. Okay. Yeah. Okay then.
Sir, we
So
will make a request to NPTEL to share the questions if possible. We all, if can make a cumulative request, then perhaps they may share.
yeah, I would encourage you to do that. Please go ahead. Um, from my end, I can request. Sorry about that. I can request Bhaskaran sir because he only makes the questions as far as I know, or he and another team. I'm not sure who all are part of it. Maybe professor is also part of it. I can request them if they want to, if they have some resources, but I'm not sure if they would have. But anyway, yeah, I can forward your request, but you can also parallelly write your request to NPTEL team. Uh, I encourage you to do that. Uh,
Thank you, sir. Thank you so much.
okay, yeah, thanks for your questions. Yes, Rocky, we'll cover GSP as well next week. We'll try to cover that as well. Yeah, so yeah, let's conclude for today and let's meet next week. Thanks all for attending. Okay. Next week we'll meet at 5. Okay.